All right, mathematicians, let's look at some new information and using some old to find the interquartile range and using and creating box plots. So before we jump in, we have a few vocab pieces to make sure we're all good with. So when we're talking about values that describe the spread of the data, so that kind of makes you think of range, right? Really what that is the main lesson here is we are using measures, let's fill this in, measures of variation. The word variation comes from a variety or vary or how they differ, right? From one extreme to another. So with these measures of variations there are two different types of variations. One is, like we already said, we know, it's the range. So the range of a data set, so smallest to largest, what's that difference? We already know we're calculating the greatest versus the least. And the second one is called quartiles. So fill in quartiles. This is a new one. There's three different quartiles, but quartiles is basically dividing the data into 4 equal parts. So kind of using our knowledge about dollars and quarters, and then you can think of the percentage and which percentage you fall under. Are you in the first quartile, second, third, and really fourth, but we can only communicate them in certain ways. So these are the 3 of them. So finding the quartile is also going to cut the data into fourths. So if you think of something, if you think of a whole cut into fourths, right, that would be the middle directly, and then you would have another cut, which is making those fourths, so it's really half of the half. That's where fourths come from. So what are those different names that we use if we had the data all displayed out? This median of the data values that are less than the median. So the median we know is right in the middle. And if it's in the middle and they're talking about the median that's less than, it's the middle of the less, that we call, let's see if you can see that. Yeah, you can. Quartile. But it's a specific one. It's the first. So we should have written a first quartile. And we'll write that using a shorthand of Q with a little 1 at the bottom, not a power at the top. It's a little 1 at the bottom here. Okay? So then the other one, so we'll go in order. That's your first quartile. The second quartile, so let's fill that in, is one we're more familiar with. And, well, that's just the median. Like, second one's just right in the middle. Okay? And then the third quartile is going to, Q3. That one's going to be a Q2. Now, I never see the Q2, though. They just say median. But know that the second quartile is the same thing as a median. All right, so quartile 3 is looking specifically at the median, the middle of the greater than the median. So we're on this side of the median, half of that, right there, okay? It's that specific value and for the quartile, and it's quartile 1, that specific value, quartile 3, that specific value, okay? Using this information, we're going to get more analyzing out of our data. So what that does is, in this situation, we have this data for apps on our phones. So let's go ahead, and if we're given a piece of data or pieces of data, and we are going to look for the quartiles, including the median, we need to put them in number order, just like we would for the median. So putting this in number order, and be careful. They are very conscientious of writing properly and using commas and then the ands before the last one. But sometimes don't forget about that one right there. So let's put these in number order. Go ahead, and I want you to put them in number order, and I'm going to pop mine on here, and let's see if we get them all in the right spot. All right, and like magic, I have all my data in number order. Check to see. We should have believe it's 10 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you should have 10 pieces of data in number order now. And let's start seeing if we can figure out these quartiles. So starting at the median, we need to find that middle one. So remember, if we have 10 pieces of data, are we going to have a direct middle number, or are we going to have to find the middle of the two middle numbers? And in this case, we're right in the middle of 17 and 18. That is still mathematically easily figured out, because that's just going to be a 17 and a half. Now, I know you can't really have a half of an half, right? But for this case, you're still giving a quantitative value to that. So if you actually had to say a final answer of how many true apps someone was using, you would know you would have to round down, because you're not using half of one. So using labels here, 17 and a half apps is our middle point. And so because we know that middle point, that quartile 2, we can figure out our first and our second. So remember, our quartile 1, or our third, our quartile 1 is going to be half of the lower. So I want you to make a note of that when we're looking at that, let's kind of analyze that this section right here, it's called the lower. And we are going to label that with just a lower. We don't always have to. I want you to do for this one. And then for here, we're going to label, it looks like we have more, but there are more digits, so it's spread out longer. It is still just 1, 2, 3, 4, 5 digits, and this is, or numbers, and this is 1, 2, 3, 4. Oops, I circled edit, excuse me. Let's go back here, and that circle does not belong around that 17, because it's not the median. My arrow's showing median. So now I have 5 and 5, right? 1, 2, 3, 4, 5. So this is the lower, and this is the upper. So let's label that, finish labeling that, upper. And the middle of the lower is going to be our quartile 1. What do you think it is? This one's easy because there's a number right in the middle. There it is, 15. The middle of the lower is 15 apps. And then what about the upper? 19 apps. Great, so those are just a few additional, so mean, median, mode, range, quartiles. That's still pretty basic. So now we're going to take that information from quartiles, though, and analyze what's going on in our data. So when we are looking at this information, we're finding actually the distance between the first and the third as well. So first and the third quartiles, that 15 and that 19, we're looking at the distance between those two. And so that is called, it's IQR, which stands for interquartile, goodness, it's too late at night for me. Quartile range. I'm going to still edit that. There. Sloppy. Interquartile range. So, with the interquartile range, you have, it's bothering me. Is it bothering you? I bet. All right, the interquartile range, it's the quantities between the first and the third. So it represents the middle of the half, or the 50%. So if you're falling in here, you're in the 50% of the data. So the lower interquartile range, the lower it is, the closer to the middle half of the data is to the mean. That was wordy. So let's look at that. So to find the interquartile range, I'm going to do this in green. you take your quartile 3, which is in this case 19, and you subtract it from your lower 15, and you get 4. So your interquartile range is 4 apps. So let's go back to that wordy statement. So if we have the interquartile, if it's low, the lower the interquartile range, that's pretty low, right? That's a really small number, especially pretty low comparatively here. That means it's closer to the middle half of the data, is to the median. So it's closer to that median. And then also we have the regular range. The regular range is just 36 minus 4. What we're used to, largest versus smallest. So we have a 32, okay? So we're gonna do more of this. I think this is the bulkier part of what we're doing here. And it actually helps to then make box plots to see this whole like 50% and percentiles. So this is a box plot. It's also known as, and on your paper you might want to circle this, as a box and whiskers plot. I think that's fun. A little bit harder, more to say, not harder. But here are your whiskers. So I'm putting some green over there, and I'm gonna kind of just bring an arrow around for my notes purposes, and this is a whisker. You're gonna have to analyze these whiskers, and because they can be different lengths depending on your data. So your whiskers are actually forcing a line out to your furthest points of your data. So this would be your smallest, and they call this, it's interesting. You would think like it's the smallest, it's the greatest, but it's not. They call it the lower extreme. So this right here, let me get a different color, is the lower extreme. Yeah, it's still least, it's still the smallest. Just a new word to add to it, right? And then this is as big as your data gets. So they don't call it greatest, it's called the upper extreme. So label that. Still means greater, still means the largest. So those lines, those whiskers are going to go all the way out, which really is then your information for your range, right? You have your greatest piece of data and you have your lowest piece of data. Now it's not a line plot where you have all of your data plotted on there, but you do have your quartiles. So right in the middle here, let's label this one. This one, if it's, I said it's the middle, it's the median, which is also known as what quartile? Don't goof, because we're used to just saying these two quartiles. This one is a quartile, it's quartile 2. And then your data goes, if this is halfway, then, and this is your smallest and this is your largest, these two pieces are cutting your data into those fourths then. So you have your 50%, and then to make your other chunk, right, your 25 and your 25 and your 25 and your 25. So this is your quartile 1, and this is your quartile 2. Now going back to those percentages, this is where you can start analyzing your data more, is that if a piece of data fell within this value, the median and the quartile 1, you're in 20% range of being in the middle, right? You're kind of in that close to the median. And then same thing for the other side. If you're within that quartile, that's 25%. Now because we're in fourths, that's 25%, right? And that's 25% too. But this is kind of looking at if this is the middle point, and if you fall within that, how close you are to the middle point, or how much of an outlier, and we'll start talking about those more too, based on if you're outside of that box. So the box in the whiskers. So you're actually going to be making these two, not with all of the data, but with the median in the quartiles and then the ranges, right? So what we just talked about are those 25%. Now the thing I want you to take from this, and I'm going to highlight it, and this can be wordy too, is about if it's longer or shorter. So I think it's going to make more sense when we actually see an example. But if we do some quick skimming here, because I did say all of this pretty much, is then we get to here, a longer box or whisker. So if a box or a whisker is longer, it indicates the data is more spread out than that section. So the box being bigger means the data is spread out. If the whisker is longer, the data is more spread out. It could be either one. So I'm going to even draw like just one little box here. Let's pretend that's the median. Here's the other part of my box. You could have a really long whisker, or you could have, and I'll draw another one, or you could have a short one. So what it's saying is here is the longer the whisker or even the box could be really long, then the more it's just spread out, because your data is it's connecting all the way to the smallest piece of data. And then don't get fooled though, it's saying. So just because the box is longer or the whisker is longer, it does not mean that there's more data values in that section. It's always going to be 25% of the data, because if you are actually finding that quartile, you are finding that halfway point. So it's not counting or considering how many pieces of data there are like you would like a line plot. It's more of you've already calculated that, and the box and whisker are only those quartiles and ranges. Okay? All right, ready? We have 3 examples to do, and then you'll be running off and doing this on your own practice-wise. Okay? So example 1, we have the range. We're going to just find the range given this data. And then we're also going to find the interquartile range, and then we're going to describe that a little bit too. So we have some house cat, cheetah, elephant, random animals is what I would say. We are going to take this data, and because we are working with quartiles range, we always need to write out our data and put them in number order. So let's go ahead and put these in number order. Let's see if we can do it. So 1 for sure. Spider is the slowest, thank goodness, so I can run away. We have our 8. We have our, looks like what, 25. And I gotta check them off as I go. And then 30. And then 50, and then a 70. I always have to check 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, we got them all, and they're in number order. All right, so right now, I'm gonna pause, and you are gonna find the median, quartile 1, and quartile 3. Let's check those before you do the interquartile range. I know you could do, but let's hold off on those. All right, so what do you think? We don't have a number right in the middle, do we? So, tied. What's in the middle of 25 and 30? What are you gonna do to figure that out? So anytime we have 2 in the middle, you can add them together and divide by 2. That's finding the mean of the 2 middle. So if you add those together, you get 55. 55 divided by 2, don't get an even number. 27.5. Of course, a half is fine too, right? And we're talking about miles per hour here. So that's our median. Now that we have this median in place, we can then find our quartile. So what quartile did you find? This one's easier because there is a dead set middle of it. So in between, we have a 1, an 8, and a 25. I found that quartile. Quartile 1 is 8 miles per hour. And quartile 3, 50 miles per hour. All right, so range, 70 minus 1, 69 miles per hour. And then the interquartile range. What do you do to calculate those? So yeah, you take the 50, you subtract the 8, and you get a easy whole numbers, right? 42. All right, so this is what we get from it. Again, mean, median, mode, range, quartiles, interquartile range. What does it all mean, and how are we analyzing it? So to start off, I'm going to have some statements that you'll fill in the blank for, and you'll get more comfortable with how you're supposed to describe it and things you're supposed to say in order to describe it. This one's a pretty quick statement. So the spread of the middle 50%, there's our spread of our middle 50% of the data, is 42. This means that the middle half of the data values can vary by 42 miles per hour. So if you're in the middle, it could be varying from 42 miles per hour. So the smaller it is, right, that we're going to be able to analyze that, of how much it could vary, or the bigger it is, the more it can vary. So we have a pretty big variety here, right? Sometimes I think that data is more obvious of how spread out it is as well. But this is when we're going to be making some box plots. And some are going to be made for you. You will have to make your own, even on the test. But you also have to identify what's going on in them too. So let's check this one out. And on example 2, already made for us. And you are going to fill in these blanks based on what we see, okay? Remember, this is not all of the data. This is the annual snowfall totals for some city over 20 years. So you don't have 20 years worth of data represented on here, but you do have the lower extreme, the upper extreme. This would be the median, this would be quartile 1, and this would be quartile 3. So using that, we can answer this statement, okay? I know when it's someone else's words, it's hard to tell what we're going to fill in here, but we'll think through it together. All right, the annual snowfall ranges, keyword there, ranges from about, it's regular range. Now this one's interesting because they're not perfectly on a line. So you're going to go to the closest line on the line plot as you can get, right? So we're pretty close to that 250. Oh, I should start with the smaller one. Let's start with the smaller one. So 250 is over here. This one's about what? It's not right on it, but it's really close to 115, wouldn't you agree? So 115 inches to about 250 inches. That's our range. Now they're talking about the middle half of the data. So middle half of the data ranges from about how much? So when they're talking about middle half, they're talking about the box, right? The middle half ranges, so there's our range, our quartile to quartile. That's not right on a line, but it's closest to the 140. 140 inches to the, and that's not right on a line, but it is directly in between. Can you tell what that would be then? So that'd be 190. That would be 195. So our middle half is our box, and that's our range. Okay, now because the boxes are shorter than the whiskers, so see how these boxes are shorter than how far out those whiskers go? What do you think the variation is? So is it less or greater than from the data? So when it's talking about the variation, it's the variation in here, right? Since the boxes are shorter, they're closer to the middle, it's less. There's less of a variation, okay, among the middle half, because that's where we're specifically focusing. And for short writing, I'll put just a half. So the variation wasn't about all of the data, It was about just it within that middle, between the quartiles. So having this variation means that there is a greater consistency among the middle 50% than either of the whiskers. That was a lot. Than either whisker or whiskers. So let's pretend these, I put your test scores, measurement test, one up here. If I said this was the median, if I put this up, you would see that there's not much of a variation of scores. A lot of them fell, or they're not a lot of them, but it's close. So that halfway point on the lower and the halfway point on the upper are close to still being in the middle. So you're not going to have any as many possibilities. They're all going to be really consistently close scores together. So that would be like me saying, most people got this score, but this was the middle, like this was a middle score, so a lot of people were around that. You would see a box like that. Now, could there still be someone out there who really tanked it? Mm-hmm. Could there be someone who got like a 100%? Sure, but that's why the whiskers are so long, okay? All right, last example. So now we have some car speeds, and we're actually going to make the box plot, the box and the whiskers. So same thing, okay? So let's get this data organized first. List them out. All right, do you have them listed? Let's check. When I first wanted to jump into this one, I was antsy. Were you antsy to just put the box up there and put the whiskers up there? You really can't and you shouldn't. We need all of these in order. So I know you can see the ranges pretty easy probably. So it's looking like 19. I got that one. I got a 20. No more 20, but I got a 23. Oh, got a 22. I caught myself. And then a 23. And then any more, we got a 22, 25s. So 25, 25. And then looks like a 27. And then looks like a 34's next, yeah. And a 35. And then a 40. Got them all. So you might have easily been able to see the range of it, and we do put those dots. So kind of like a box plot, but we're going to put a dot for just the information we need for a box plot. So I'm going to take and start off by doing the ends of my whiskers. So my whisker is going to go from 19, and it's like weird, like the dot just floats. It's not right above the line. It's just hanging out up there, right above 19. It's going to go all the way to 40. So here's my 40. Okay, and see if I can get a bigger dot. Ooh, that's going to be aggressive. Really, if it's too small, you're not going to be able to see the dot parts of it. All right, now we need to find the middle in order to find the ends of our box, because those are our quartiles. So what's the middle piece of this data? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're not going to have a dead center. We're going to have a middle of the two. So which one is, what are those? So as we go in, 1, 2, 3, 4, we're in the middle. Right here. So if it's 25, in between 25 and 25, it's still just going to be a 25. So that is going to still be way too big of a dot for me here. That's our middle point. Come on, you can do it, little dot. 25. See, that's not going to work. It's covering too many spots. So definitely need something smaller here. So when you're really taking your pencil and making yours, that's quality. All right, so now I have my median. Now we need to find our quartile 1 and quartile 3. So that's where I think it's not, you really still need to have this all listed out. So for the lower, we have a 21. For the upper, we have a 34. So now we have our ends of our boxes, but we still put a dot there. So 22, it's going to be right here. And we have 34 right here. Don't mix up these dots and what's what here, but I'm going to use different colors so you can see the difference between my boxes and my points. So we have our box is happening here, right? Still going to cut that because it's showing our middle, our median, and then I'm still going to connect out to my whiskers. Good thing we don't have to draw too many, right? How's your box looking? But you can definitely see this is a different variety. So what we're going to analyze here, like, okay, that's short, and this is a big chunk. So this is 25%, but this is also 25%. So kind of how it's just spread out, and then our whiskers being shorter on this side, and definitely different on the upper side. Okay, so let's see how we're going to analyze our data now. So record speeds range from what to what? Well, we have that, 19 to 40, right? And then, so the middle half of the data range, right? The middle half ranges, so that's basically asking for the quartiles. We have our 22 to our 34. Now let's analyze. Because the boxes are blank than the whiskers, what would you say? Compare the boxes to the whiskers. Are they longer or shorter? They're longer. I know this one is short, but the boxes overall are bigger than our whiskers. There is, what is that saying then about our variation? Is there more of a variation between our middle to our data, or is there less? Well, if our boxes are long, then there's a long variety that you could fall in. So it's more. There's a more variation compared to the middle of the data. So having more of a variation, what does this mean? That there is less, grammar's not my thing, but when you go to put your answers in online for your practice, it uses the word lesser. I don't use the word lesser. Maybe I should, but I would say less. Having more of a variation, right, means that there's less consistency. It's not everyone kind of fell around that same area. And so you're not consistently among that 50%, okay? All right, you are ready to practice. So you are going to be analyzing box plots. You are going to be selecting ones that are correct. You are going to be figuring out quartiles, ranges, and interquartiles. You've got this. Good luck.